I will be explaining what a limit is, because a limit is one of the most fundamental pieces of calculus. If you don't understand what a limit is, you are gonna have a difficult time understanding the nature of calculus. Therefore, I want to explain what a limit is by giving a concise example. And to be more specific, I want to give an example in an industry that I'm currently working on, and that an industry that might not appear often to our perception, but it is present on a daily basis around us. That's the construction industry. That's the construction field. If you go to walk to the city, you will realize that there is always something going on. You have a high possibility that you will encounter someone with a hard hat or a vest, or use any type of construction. One can do construction on a large scale or on a small scale, on one's backyard or on an industrial complex. Anyway, what a limit does is that it shows you the behavior of a function by inputting an independent variable. So you can input an independent variable and see the behavior of a function. You know how that function will behave if x variable it's inputted in that function. And perhaps there is always a function. There's a function for everything in life. The thing is that one has to find the proper variables for that function, but everything can be turned into a function. Every single practice, every single movement, every single task, everything is a function. One just has to be aware, accurate, and sure about what the variables of that function is. Anyway, let's say, as I said, I'm gonna use an example using concepts and ideas from the construction industry. Let's say a subcontractor, or for the sake of a better name, a vendor, a supplier, someone who's selling you something, gives you a formula of concrete. Let's say this supplier is your concrete supplier, and he gives you the formula, the linear formula, which is unlikely, by the way. It's not that easy. I don't think it's ever gonna be that easy, but this is for example's sake. Let's say the supplier gives you a linear formula, right, of the concrete. So basically, this is the cement or concrete formula. So basically he tells you, hey, just take into account that this is gonna be your byproduct of concrete, depending on how much concrete you need, or depending, the area, which is another function that you're gonna need. But this is just for this particular example. Like I said, construction is a complex, it's a dynamic system. It's a very complex dynamic system, which makes it beautiful. But anyway, let's say we put 2 bags of concrete into this machine. 2 bags. Therefore, the limit of f of x, which in this case is the formula of the machine, how many concrete the machine is doing. Therefore, the limit of x squared minus x plus 10, as x approaches 2 bags, so as this number equals 2, what is it? So let me just break it down. This is what the machine produces, right? So there is 2, of course, this is too easy. This is an easy example that anyone can figure it out by just plugging 2 right here, and then getting the number. But what the limit does is that it tells you the behavior of a function. You can play with the limit. that's basically the purpose of the limit. Instead of just plugging the number there, you can estimate how much the function is gonna oscillate between. Let's just draw an example, for example. So the graph of this function is an exponential function, so it goes like that. This is x2, which is the 2 bags, which is right here. So yeah, of course, I mean, like I said, we can figure out how much this number is by just plugging the numbers. However, by just plugging the x, However, what the limit does is that tells you the behavior of the function. It tells you all of these values and all of these values, so you can play with it. You can estimate how the function is going to behave at certain close inputs of this. So let's say 2.3 bags, right? Instead of plugging all of this to 2.3 squared minus 2.3, which of course it will be more accurate, one can just approach the limit x approaching 2, which will give us, so 12. So for 2 bags of concrete, we're gonna have 12 cubic yards using this machine. You know, it's a miracle because of course that never happens, but I mean, it would be cool if it did, but that's the idea. So you will know that as the limit as x approaches 2, using this function, which is the function of the machine, there's gonna yield 12 cubic yards of concrete. Again, you can plug in this number, or you can also plug in less, which is 0.9 or 2.009, and it will always approach this number, which is it's a way to tell the behavior of a function, basically. Of course, this is a simple function, but there will be times where you are gonna have complex functions and complex inputs, and having a limit will evaluate how much it's gonna oscillate between here. I hope that makes sense. This is my first time making a video like this. This is my first time teaching math, but I like it. I hope you understood, and stay tuned for more examples. What the limit does is that it tells you the behavior of the function. Therefore, you have this function. You can estimate how the behavior of the function is gonna behave. It would be better to show you with an example. Let's say, therefore, just to let you know, the notation of a limit goes like this. As limit of f of x approaches a, then of f of x, then a number. This is just a variable for a number. Okay, so how can we transcribe this into this? Using words, using a real life example. So let's say this is the formula of a limit. Okay, so as the limit of x approaches a using the equation of f, then it comes a number. Therefore, the limit as x approaches, like I said, we can put an arbitrary number. For the sake of this, we're gonna put 2, right? Let's say, how many cubic yards is 2 bags gonna create, if that makes sense. So let's say the vendor puts 2 bags into the machine. How many cubic yards of concrete is gonna yield? It's gonna come out as a byproduct.